Okay, general solution. If you notice on the group, I made a whole bunch of short videos on that covers type 1. I also sent you guys a document that has type 1 sort of summarized. I'm going to move on to type 2. Please go look at the videos for type 1, because if you don't understand type 1, you won't be able to go on to the others. On that note of type 1, type 2, type 3, I have written it like this. I personally do not like calling it type 1, type 2, type 3, because you guys tend to get confused and want to put it into a box. So personally, I don't like using it, but if you guys find this easier to understand, then that's great. Okay, and we'll work with it. Anyway, type 2 is when we have sine and cos of the exact same angle. Okay, what you then do in this one here is you're going to use this identity. Sine of something over cos of the exact same something gives us tan of that something. So I'm going to divide here by cos 2 theta plus 30 degrees. And on the side here, cos 2 theta plus 30 degrees. Right? Once you've done that, this idea becomes tan. This becomes tan 2 theta plus 30 degrees. And the side here ends up becoming 1, because cos over cos of the exact same thing is 1. Once you get to this point, you need to find a reference angle, right? And a reference angle, because this is a special case, you would end up having it being at 45 degrees, right? Plus k times 360. No, sorry, k times 180. But we can also work it out, and you can work it out by doing this here. You're going to press shift tan 1, and you're going to end up with 45 degrees as our reference angle. So basically 2 theta plus 30 degrees is equal to 45 degrees. Once you get to this particular point, what you need to ask yourself is, in which quadrant, can you see over here it's a positive number, in which quadrant is this positive? And the answer to that is in quadrant 1. Okay, if you're using what the textbook suggested, then your way of doing this would be slightly different. I use the method of explaining with quads, right? So we know 2 theta plus 30 degrees equals 45 degrees plus k times 180 degrees. And you'll see my other videos explain why 180 degrees and 360 degrees for the sine and cos one. Once you get to this point, we just need to simplify or solve. So I end up with 2 theta equals 45 degrees minus 30 degrees plus k times 180 degrees. Divide everything by 2. This here is going to give us 15. Divide everything by 2, so I end up with theta is equal to 7,5 degrees, because 45 minus 30 is 15. 15 divided by 2 plus k times 90 degrees. When we do general solution, please don't forget to add k is an element of integers. Okay, then the second one that we have, or well, it's type 3 here. The second type that we have is going to be where we have sine and cos, right? But the angles are different. In this particular case, we're going to end up using our reduction first. So over here, I have sine 2 theta plus 30 degrees, but on the side, I have cos theta. So we cannot do what we did above here. Instead, you pick the easier side. In this case, this is the easier side, and you end up making it okay, write it like that. It's easier to understand. Okay, like that. So basically this side and this side are exactly the same. To find our reference angle, what you would do is just drop the sine and sine. So we end up with 2 theta plus 30 degrees is equal to 90 degrees minus theta. Okay, that's our reference angle. Then you ask yourself, where is sine positive? Sine is positive in quadrant 1. So in quadrant 1, we're going to have 2 theta plus 30 degrees equals 90 degrees minus theta, plus k times 360 degrees. We're then going to simplify this. So this is going to be 2 theta plus theta equals 90 degrees minus 30 degrees is 60 degrees plus k times 360 degrees. All I did was I took the thetas to one side and the numbers to the other side. 2 theta plus 3 theta is, 2 theta plus theta is 3 theta equals 60 degrees plus k times 360 degrees, and so divided by 3 divided by 3 divided by 3, theta is equal to 20 degrees plus k times 120 degrees. Okay, so that's just for the solution in quadrant 1. We need the solution in quadrant 2 as well. In quadrant 2, we know that the reduction is 180 degrees minus theta. So on this side here, we're going to have 2 theta plus 30 degrees equals 180 degrees minus, open bracket, 90 degrees minus theta. Where did I get that from? From this part. Plus k times 360 degrees. We're going to simplify. This is 2 theta. This side here, we're going to have minus, and minus gives me a plus. But when I bring it over, it's just going to be minus theta. Okay, 180 degrees minus 90 degrees is 90 degrees. Minus 30 degrees is 60 degrees. Plus k times 360 degrees. 2 theta minus theta gives me theta equals 60 degrees plus k times 360 degrees. So we have two different solutions starting at 60 and then they continue every 120 degrees. So k is an element of integers, and that's my solution. Now type 4 and type 5 are very similar in the sense that they're both working with square terms, okay? And they're both using the identity where sine squared plus cos squared equals 1. They're just slightly different in the sense of how we use in that identity. In one case, you're going to use the identity as I just mentioned. In the other case, you're going to use the identity where sine squared or cos squared is the subject of the formula. Now, how do you know when to use what? You're always going to look at your trinomial, okay? If your trinomial in the middle has sine and cos, that means I need this term here at the end to also have a cos in it, okay? Whereas this one over here, if my middle term in my trinomial is just one ratio, it means that everything else has to be in terms of that ratio or else a perfect number, right? Like 1. So can you see this cos squared is not in terms of this. So it needs to get changed to sine squared. And that's when we're going to change its cos squared. You can change it using this one over here. It becomes 1 minus sine squared. That's the two different types. So let's try this one over here. I know I have sine and cos, so which means this number needs to have a cos. I'm first going to make it an identity, a trinomial by bringing that number over. Plus sine x cos x minus 2 equals 0. Now, if we have any number at all, you would agree that that number is multiplied by an invisible 1, right? So what I'm doing over here is I'm assuming that this here is negative 2 times 1. So 3 sine right? And there's a negative 1 next to it. So let's open up a bracket for the negative 1. Not the negative 1, sorry, the positive 1. In the place of 1, we know according to trig ratios and trig identities, this here is equal to 1. So this becomes sine squared x plus cos squared x, and then this is equal to 0. Right? We're going to now distribute. So using grade 8 and 9 knowledge, minus 2 sine we're now going to look for like terms, and I can see this and this are like terms. So 3 minus 2 gives me 1 sine squared x. Sine plus sine and cos, nothing got changed by that. And over here I have minus 2. Now what's a really helpful tip is, in your paper or on the side of your paper, what you can do is you can represent this by any variable. I'm going to call this x squared plus xy minus 2y squared. That's what I'm doing. I basically represented by sine squared x is just x squared, my sine x is x, my cos x is y, and my negative 2 cos squared x is negative 2y squared. I can then simplify this, and if you get stuck with this, you can use your, if you have a silver calculator, you can use that on equation mode, or if you have the normal gray calculator, what you're basically doing, if you don't know it, okay, what you're basically doing is you're using the quadratic formula. Quadratic formula says minus b, so minus, our b value is 1, plus square root of 1 squared minus 4, a value is 1, and our c value is negative 2, all over 2 times 1, and it gives us an answer of 1. So let's write this down. If it gives us an answer of 1, that means over here should have a minus 1. But remember, we're working in terms of x and y, so this should be a y, this should be an x, right? You don't have to write this one. I'm just showing you where I got it from and what it turns into. I'm going to change this. It's going to be a minus, and we get negative 2. So over here, if it's negative 2, it should be positive 2. And because we're working in x and y, let's put an x and a y. Right. But that's not what we wanted. We wanted it in terms of our trig ratios. So remember, we said x is basically sine. So this here is going to be sine x plus y, we said was cos. So plus cos x, right, in one bracket. In the other bracket should be again x, which is sine x, plus 2, and our y should be cos x equals 0. We now have it in such a way where the first bracket is equal to 0, the second bracket is equal to 0. So I have sine x is equal to negative cos x, or I have sine x is equal to negative 2 cos x. Right? Sorry. What we can then do once we get to this point over here is use our type 2, because can you see both of the angles are exactly the same. One is sine, one is cos. So you're going to go back to this stuff over here of type 2, and you're going to divide both sides by cos x until you get tan x equals to whatever, and continue with it. Please don't forget, I'm not completing everything. You need to work out the general solution for this one. And the last one, this one here, we have cos squared, but here I have sine. So I'm going to change my cos squared so that it's something in terms of sine. So this here is going to be 3 times 1 minus sine squared beta. That's 5 sine equals 1. Again, where did I get this from? We know that cos squared of something is the same thing as 1 minus sine squared. So I had cos squared, I changed it to 1 minus sine squared. We're distributing this into the bracket, so I end up with 3 minus 3 sine squared beta plus 5 sine beta. I'm bringing the 1 over. Right? We're looking for like terms. In this case, it's this one and this one. So I have negative 3 sine beta plus 5. Right? 3 minus 1 gives me 2. Okay. Again, once we get to this point, this is the same thing as negative 3x. Oh, wait. Before we do that, I don't like negatives. I don't know about you. So what I'm going to do is I'm going to divide everything by a negative. So I end up with 3 sine squared beta minus 5 sine. That looks better to work with, right? This here is the same thing as 3x squared minus 5x minus 2. Once you get here, you can go to your quadratic formula. So our values, or if you have a silver calculator, just plug it in on a silver calculator. Minus, our b value is negative 5. negative 5 plus square root. Again, b value, so negative 5 squared minus 4, a value which is 3, and c value which is negative 2. All over 2 times our a value of 3. And it gives us the answer 2. So if it gave us 2, it means our bracket should be x minus 2. Right? This time we're not working with a y or a different variable. And we just change in this here to be negative. It's negative 1 over 3. So if it's negative 1 over 3, it becomes 3x plus 1 equals 0. We didn't want it in terms of x, we wanted it in terms of sine. So this here is going to be sine beta minus 2, 3 sine beta plus 1 equals to 0. Please don't forget to do the step. You actually get marks for this, right? And then sine beta equals 2, or 3 sine beta equals negative 1, sine equals negative 1 over 3. You would notice that if you type this in on your calculator to find a reference angle, shift sine 2, it gives you math error. And why is that the case? That's the case because if I had to draw a sine graph, let's sketch one, the highest point it can go to is 1. This is asking us where is this graph equal to 2. But it can't even go to 2 because the highest point it gets to is 1, and then it turns around, etc. Right? So this one here would be not applicable. In this case over here, we can work it out. This is type 1. You can go back to the group and see the videos I sent. You need to find the reference angle. And once you find the reference angle, you find out in which 2 quadrants it lies because it's negative. And that would be in quadrant 3 and 4. I hope this helped.